Hello, my name is Preethi, TRB Padikalam Vanga. Today we are going to see the set of 5 questions based upon the basic circuit laws. The first question, the time constant of the circuit with inductance 240 millihenry in series with resistance 20 ohms. They have given you 4 different options. So we know that the time taken by a circuit to reach 63% of the steady state value, that we call as time constant. It is always represented to be as tau. Tau is equal to L by R. Tau is equal to L by R. L is the inductance and R will be the resistance. So the value of inductance is given to you as 240 millihenry. So 240 into 10 power of minus 3 henry divided by resistance is 20 ohm. So when you solve this, you will get that 12 that is tau time constant in terms of second, we can write 12 millisecond. So you can choose the option number D. Okay. And the second question, which of the following laws is applied for the mesh analysis of the network? So we should understand that the mesh analysis is a method of analyzing network with the help of the KVL equations, Kirchhoff's voltage law. So normally we have to represent the mesh analysis to be as KVL plus Ohm's law. Okay. When you go for the node analysis, we have to represent to be as KCL plus Ohm's law, Kirchhoff's current law plus Ohm's law. So mesh analysis means KVL plus Ohm's law. Node analysis means KCL plus Ohm's law. So please make a note of it. But here we have to represent as KVL. The option A will be that. Kirchhoff's voltage law, Kirchhoff's current law, Kirchhoff's first law and Kirchhoff's junction rule. In that way they have represented. Our option will be option, that is KVL. And the third question. So resultant voltage between the terminal A to B, they have asked you. So they have given you that 12 volt, 5 volt, 8 volt and 6 volt. The same type of question we have already solved in the previous video. And let us solve this. Depends upon the polarity of the voltage. So represent as plus, minus, write all the terminals first. Yeah. See here. So plus 2 minus, it means that we can write VAB is equal to 12 volt. Minus 2 plus, it is, we can represent VAB is equal to 12 volt minus 5 volt minus 8 volt plus 6 volt. So by adding all the voltages, we will get 12 minus 5 is 7. 7 minus 8 is minus 1. Minus 1 plus 6 gives you 5 volt. So VAB is equal to 5 volt. We need to understand only one thing. Plus 2 minus means represent plus 12 volt and minus 2 plus means minus. Okay. And next one, we are moving into the fourth one. How many dependent sources are there? The options are given you as 1, 2, 3 and 4. And dependent sources, it means that in the theory of electrical network, a dependent source is a voltage source or a current source whose value depends upon the voltage or current elsewhere network. Am I right? And in the case of the dependent sources, we'll be having the 4 different types. There are, we already know that VCVS, VCCS, CCVS and CCCS is nothing but voltage controlled voltage source, voltage controlled current source, current controlled voltage source and current controlled current source. So we will be having the 4 different types of the dependent sources in the electrical network. Okay. The last one, how to find out the current I4 in the given figure. So we know already about the KCL. So Kirchhoff's current law, the algebraic sum of the electrical currents meeting at a common point is equal to 0. We can write summation of IN is equal to 0. And see, let's have a node N here. The incoming current will be, we have to represent to be as I1 and incoming current is I2. The outgoing currents are I3 and I4. So we can represent the opposite direction minus I3 and minus I4 as summation of all currents equal to 0. So now our duty is to find out the I4 now. So we can have I4 here. So I1 plus I2 minus I3. So I1 is what? 4 amps and I2 will be 2.5 amps and I3 will be minus 2 amps. and check what is the answer. 4 plus 2.5 gives 6.5. 6.5 minus 2 is 4.5 amps. Am I right? So this will be your answer. My dear friends, please like, share and subscribe. Thank you, and thank you for your support.